Welcome, one and all, to a session on artificial intelligence presented by Divya and Burgess and Sanju Mariam Thomas. Artificial intelligence. Artificial intelligence, or AI, is an area of computer science that emphasizes the creation of intelligent machines that work and react like humans. Some of the activities that computers with artificial intelligence are designed for include reasoning, which means to draw inference appropriate to the situation. Inductive reasoning is common in science, where data is collected and tentative models are developed to describe and predict future behavior. Also, learning. There are different forms of learning. The simplest learning is trial and error, which can be done using neural networks and machine learning. Problem solving. Problem solving in artificial intelligence is characterized by a systematic search through a range of possible action in order to reach some predefined goal or solution. Perception is analyzing a different viewpoint depending on the angle of view. AI perception is well advanced to enable optical sensors to identify individuals, autonomous vehicles to drive at moderate speeds on the open road, and robots to roam through buildings collecting empty soda cans. These are some of the activities which are done using artificial intelligence. Now, some of the applications of artificial intelligence. Game playing. There have been many machines that can play master level chess, which can be bought for a few $100s. These machines work on the principle of AI, and they can play well against people mainly through brute force competition. To beat a world champion by brute force and known reliable heuristics requires being able to look at 200 million positions per second. Speech recognition. By the 1990s, computer speech recognition reached a practical level for limited purposes. Thus, United Airlines has replaced its keyboard tree for flight information by a system using speech recognition of flight numbers and city names. This has been quite convenient. On the other hand, while it is possible to instruct some computers using speech, most users have gone back to the keyboard and mouse as they are still more convenient. Understanding natural language. Just getting a sequence of words into a computer is not enough, and also putting in sentences are not enough either. The computer has to be able to understand the domain or context about the text which is being inputted, and this is currently possible to only for a very limited number of domains. Now, heuristic classification. It is one of the most feasible kinds of expert system given the present knowledge of AI, which is to put some information in one of a fixed set of categories using several sources of information. For example, in the case of advising whether to accept a proposed credit card purchase, information is available about the owner of the credit card, his record of payment, and also about the item he is buying and about the establishment from which he is buying it. Example, about whether there has been previous credit card frauds at this establishment. Through this methodology you can do is an example of heuristic classification. Now, computer vision. The world is made up of three-dimensional objects, but the inputs to the human eye and computer's TV cameras are two-dimensional. Some useful programs can work solely in two dimensions, but full computer vision requires partial three-dimensional information that is not just a set of two-dimensional views. At present, there are only limited ways of representing 3D information directly, and they are not as good as humans are used to. Robotics. A robot is a programmable, multifunctional manipulator designed to move materials, arts, tools, or specialized devices through variable programmed motion for the performance of variety of tasks. They need special hardware with sensors and effectors. Expert systems. Expert systems are one of the most recent innovations in artificial intelligence. A knowledge engineer interviews experts in a certain domain and tries to embody their knowledge in a computer program for carrying out some tasks. How well this works depends on whether the intellectual machine mechanisms required for the task are within the present state of AI. When this turned out not to be so, there has been many disappointing results. One of the first expert systems was Mycin in 1974, which diagnosed bacterial infections of the blood and suggested treatments. It did better than medical students or practicing doctors, provided its limitations were observed. Namely, its ontology, that is, the meanings that it has taken in, included bacteria, symptoms, and treatments and did not include patients, doctors, hospitals, recovery, and events occurring in time. Its interactions depended on a single patient being considered. In the present state of AI, this has to be true. The usefulness of current expert systems depends on their users having common sense. Now, let's discuss the limitations of artificial intelligence. One of the major limitations of artificial intelligence is its high cost. The creation of AI requires a huge cost as they are very complex machines. Their repair and maintenance also requires huge amounts of investment. The installed software may need frequent upgradation to cater to the needs of the changing environment and also to make the machine smarter. In the case of severe breakdowns, the procedure to recover lost codes and reinstating the system might require huge amounts of time and cost. There are no replicating of humans. Intelligence is believed to be a gift of nature. Machines do not have any emotions or moral values. They perform what is programmed and cannot make the judgment or right or wrong. Even cannot take decisions if they encounter a situation unfamiliar to them. They either perform incorrectly or break down in such situations. There is no improvement with experience. Unlike humans, AI cannot be improved with experience. With time, it leads to wear and tear. It stores a lot of data, but the way it can be accessed and used is very different from human intelligence. Machines are unable to alter their response to changing environment and need to be programmed to do so. No original creativity. Humans are highly sensitive and emotional intellectuals. They see, hear, think, and feel. Their thoughts are guided by feeling, which completely lacks in machines. The inherent intuitive abilities of human brain cannot be replicated. Unemployment. The replacement of humans with machines can lead to a large-scale unemployment. Humans will lose their creative power and will become lazy and also think in a destructive manner. They can create havoc with these machines, as AI in the wrong hands is a serious threat to mankind. The potential risk of intelligence. The field of AI is advancing rapidly. There has been dramatic breakthrough in the past in the fields of image and speech recognition, autonomous robotics, game playing. Also, in the coming decades, there will be substantial progress with new scientific discoveries, cheaper and better goods, much more highly intelligent medical advances. But with it comes the risk of privacy, bias, inequality, safety, and security. Superintelligence. AI systems become more powerful, more general, and become superintelligent, superior to human performance in many or nearly all domains. This might transform the economical, social, and political setup, which leads to various risks or chances of misuse. Machine learning research into safety is now being led by teams at OpenAI, DeepMind, and the Center for Human Compatible AI. This community is working towards safe and beneficial superintelligence, and this community has developed shared strategies to allow the benefits of AI advances to be safely realized. Thank you.